Hello students, welcome to today's mathematics session. Last class we were in the chapter cubes and cube roots and we were solving brain teasers questions. And we have completed from question 1 to question 3 solving. So let us begin the class with solving question number 4. Question 4, find the cubes of. So we need to find their cubes, not cube roots. We need to find their cubes of 0.6, minus 3.1 and minus 0.01. So 0.6 cube is nothing but 0.6 into 0.6 into 0.6. We know that 6 cube is nothing but 216. And after 0.1 decimal, after 0.1 decimal, after 0.1 decimal means 3 decimals. So from right side 1, 2, 3 points. So the answer is 0.216. Now moving to second question, that is minus 3.1 whole cube. We know that cube of negative is always negative. So minus 3.1 into minus 3.1 into minus 3.1. Then cube of negative is negative. So minus, then 3.1 into 3.1 into 3.1. So the answer is 29.791. Next third question, that is minus 0.01 cube. So here also we have negative. So negative cube is nothing but negative itself minus into minus 0.01. Answer is minus. So 1 into 1 into 1 is nothing but 1 itself. But after point, decimal point, we have 2 digits, 2 digits, 2 digits. 2 3s are 6. So 6 digits we should get. 1 is already there. 2, 2, 3, 4, 5, 6. So the other digits will make it as 0 towards the left of 1. So the final answer is minus 0.000001 is the answer. So we'll move to question 5 now. Find the value of the following cube roots. Here given cube roots value we need to find, children. So here cube root of 0.008, the second one cube root of minus 64 divided by 1331, third cube root of 27 into 2744, children. So here if you know the cube number you can directly do it, children, or else you can go for prime factorization to find its cube number. So cube root of 0.008, this can be, I'll do it here 2 ways, children, which you feel easy to do, that you can go with that method. Okay, so here 0.008, this decimal I'll convert into rational number, so I can write it as 8 by, here we have after decimal point we have 3 digits, so 3 numbers, I mean 3 zeros. And here we know that 8 is a perfect cube of 2 and 1000 is a perfect cube of 10, so 2 by 10 whole cube. Then cube and cube root get cancels. Then we'll get 2 by 10 answer. 2 by 10 convert into decimal, children. Don't go for cancellation and do it. Just shift the point. In the whole number, the decimal point will be at the end of the number. Since we have 1 0, point will shift after 1 digit. So 0.2 is the answer. The another method also I'll show you here, children. Cube root of 0.008. This is OR method. You can go this or this. Okay. So here I'll not convert into rational number. Directly I'll shift it because we know that 0.008, if I remove the decimal point, its value is only the 8. And 8 we know that it is a perfect cube of 2. So here 3 digits makes 1 period. So I can write cube root of 2 and 1 period, right? So 0.0 whole cube. Then cube and cube root get cancels, then the answer is 0.2. Whichever the method you feel convenient, that method you can solve, children. So let me move to the second question solving, that is cube root of minus 64 divided by 1331. We know that under the negative will come outside the cube root. So cube root of 64 we know that it is a 4 cube. And 1331 is nothing but 11 cube. So 4 by 11 whole cube. Cube and cube root get cancels. Then the answer is minus 4 by 11. So don't forget to keep the negative sign, children. Negative sign is very important here. So moving to third question, that is cube root of 27 into 2744. 2744. Here we know that children 27 is a perfect cube, whereas 2744 we do not know, but that cube number can be found by using prime factorization method. So here we know that cube root of a into b is nothing but cube root of a into cube root of b, because we know that a is a perfect cube. Then to know whether b is a perfect cube or not, we need to check by doing prime factorization method. So let me go here. So 2744 ending with the 4. So I'll go with the 2 table. 2 1s are 2 3s are 6, 2 7s are 14, 2 2s are 4, then 2 2 6 are 12, 1 remains, 2 8s are 16, 1 remains, 2 6 are 12, then 2 2 3s are 6, 2 4s are 8, 2 3s are 6. We know that 343 is a perfect cube of 7, 7 4s are 7 9s are 63, then 7 7s are 49, then 7 1s are 7. Then here I can write 2744 is nothing but 2 cube into 7 cube. Then 2744 is nothing but 2 into 7 whole cube. Then send the cube to the either side, it becomes cube root of 2744 is nothing but 7 2s are 14. So 14 cube is 2744. Then according to question, cube root of 27 into 2744, I can write it as cube root of 27 into cube root of 2744. 27 is nothing but a perfect cube of 3, so 3 cube into 3 cube root of 2744 is nothing but 14 cube. Cube and cube root get cancels, then I'll get 3 into 14. We know that 14 3s are 42. 42 is the answer. Hope it's clear, children. Now let me move to question 6. So moving to 6th question, children. Find the smallest number which when multiplied with the 3600, that is 3600, will make the product a perfect cube. Further, find the cube root of that product. But here 3600 which is given, it is not a perfect cube. It is a perfect square but not a perfect cube. So we need to find some number that when I multiply it with 3600, then the product gives a perfect cube. So we need to know which number should be multiplied. To know that particular number, we need to go with the prime factorization method and check which factor is not in triplets. That number should be multiplied. So I'll take 3600 and let me find the factors of it. Okay. So I'll go with the 3 table. 3 1s are 3, 3 2s are 6, 0 0. Then 3 4s are 12, 0 0. Then I'll go with the 2 table. 2 2s are 4, 0 0. Then 2 1s are 2, 0 0. Then 2 5s are 10, 0. Then 2 25s are, then 5 5s are, 5 1s are. Here we can see 3600 can be written as 3 square into 2 cube into 5 square. You can check here. 3 is repeating only 2 times and 5 is repeating 2 times, 2 is repeating 3 times, and one more we have 2 which is not repeating 3 times. It is only repeating 1 time. So here the product what we get, that is 3 is repeating only 2 times, means we required one more 3. Okay, and here 2 is repeating 3 times. Okay, it is under perfect cube. Whereas 5 is repeating 2 times, that is 5 square is nothing but 5 repeating 2 times. We required one more 5, so into 5. And here 2 is repeating only 1 time, means I required still 2 more times. So I'll write it 2 into 2. What is that answer? 5 3s are 15, 15 2s are 30, 30 2s are 60. So I can write here factors 3, 5 and 2 are not in triplets. Therefore, 3600 must be multiplied by What is the product I got? 60 multiplied by 60 to get a perfect cube. And after that he asked find the cube root of the product. Therefore 3600 into 60. Then what is the answer? 216000. So therefore he is asking its cube root. So 216000, its factor is 2 cube, 3 cube, 5 cube into 2 cube. That is all the factors to be written in cubes. That's all. 216000 is nothing but 2 into 3 into 5 into 2 whole cube. Then send this cube to the either side, it becomes cube root. Cube root of 216000 is nothing but 5 2s are 10, 10 3s are 30, 32s are 60. Or you can see children, from the last we need to make the periods. So 3 numbers makes 1 period, 3 numbers makes 1 period. So here 0 0, 3 times repeating is nothing but 1 0 will come outside, and 216 we know that it's a perfect cube of 6, so 60. See, this is how we need to find the answer, children. So let me move to question 7. Evaluate cube root of 0.027 divided by 0.008. Divide square root of 0.09 by 0.04 minus 1. So here remember children, here both the chapters are clubbed together and asked the question. One is cube root of rational number and the other is square root of rational number and with integer. So here we'll solve this question. It's a very important question children. It is oftenly asked in the examination. 0.027 divided by 0.008. I am writing the question as it is. Divide square root of 0.09 by 0.04 and the minus 1. So here I can cancel the decimal point children, because after decimal point we have 3 digits. After decimal point we have 3 digits. Here after decimal point 2 digits. After decimal point 2 digits. So this decimal point, this decimal point, this decimal point with this decimal point, I can go for cancellation. That method you can do. Or the other method is converting the rational number into, converting the decimal number into the form of rational number. That method also you can follow. So square root of 0.07, I'll write it as 27 by 100. 1000. Because after decimal point we have 3 digits, so it divided by 1000. And this division symbol, I'll write it as this symbol. Okay. Then 0.008, I'll write it as 8 divided by again 1000. Then next this division symbol and square root of this also I'll convert into the form of rational number, 9 divided by 100. And this division symbol, I'll write it as this symbol. Okay. And 0.04 is nothing but 4 divided by 100 and minus 1. And cube root of, we have learnt in class 7 standard children that division changes to multiplication and reciprocal of the number. So 1000 divided by 8. Divide square root of 9 divided by 100, and this division changes to multiplication reciprocal of the number. 100 divided by 4. Minus 1. Now you can see this 1000 and this 1000 get cancels. Because of this only I said you here decimal point get cancels, because later part we have 3 digits decimal places. So you can go with cancellation. That method also you can use. Then next cube root of, so 27 by 1 into 8 is 8. Then divide square root of 9 divided by 4 minus 1, because we know that 9 1s is 9, 1 4s is 4. And we know that 27 is a perfect cube of 3 and 8 is a perfect cube of 2. So whole cube, divide square root of, under square root we know that 9 is a perfect square of 3 and 4 is a perfect square of 2. Why I am taking here square in the sense, because we have here square root and here we had a cube root. So we are using cube numbers and the square numbers with respectively. Cube and cube root get cancelled, square and square root get cancelled. Then the answer is 3 by 2 divide 3 by 2 minus 1. Again you can use the operation division changes to multiplication reciprocal of the number, 2 by 3. minus 1. Keep remember, here we need to apply the board mass rule, that is first division, multiplication, addition and subtraction. Board mass rule, that is bracket of division, multiplication, addition and subtraction. But here we have first division, so I'll remove the division, changes to multiplication. So 2 get cancels, 3 get cancels, 1s are 1s are 1s are 1s are. So 1 1s are 1 by 1 1s are 1 minus 1. So 1 by 1 is nothing but 1, 1 minus 1 is nothing but 0. 0 is the answer, children. This is very important question, children. Okay, mark down in the textbook, that is question number 7 is very important. So let me move to question number 8 in solving. Question 8. Guess the cube root of the following numbers. So we need to find the cube root of the numbers, children, and that too guessing, means estimation method we need to find. We need to find the answer through estimation number. So cube root of 6859. This is the first question, children. Clear? So in the estimation method we have the following steps. The first step is we need to take the number, that is 6859, and we need to divide into the form of groups. So groups making 3 digits from the right side to left side. So 1, 2, 3. So the first group makes 859 and the second group makes 6. So step 2. The step 2 is we need to consider the group 1. So what is group 1? The group number 1 is, group 1 is 859. In this we need to take the units place number. Units place number is 9 and we need to find its cube. Its cube is 729. In that we need to consider units place, again 9. So 9 stands in tens place. 9 stands in not tens, children, ones. Okay, 9 stands in ones place of a cube root number. Please correct it here, children. 9 stands in ones place because we are finding group 1. So ones place of a cube root number. Next, step 3. Step 3, we need to consider group 2. Group 2. What is group 2? The group 2 is 6. So 6. We need to find this 6 which lies in between the perfect cube numbers. So 6 is greater than 1 and 6 is lesser than 8. That is 1 cube less than 6 and 6 is less than 2 cube. Among this 1 and 2, which is smaller? 1 is smaller. Yes, among 1 and 2, 1 is smaller than 2. Therefore, 1 stands in tens place. 1 stands in tens place of a cube root number. Therefore, cube root of, what is the number? 6859 is nothing but ones and tens. What is in ones place? In ones place we have 9. And what is in tens place? Tens place we have 1. So 19 cube is nothing but 6859. 19 is the answer, children. So let us move to second question now. Cube root of 12167. So cube root of 12167. So here step 1, divide the number into groups. From where? From right side to left side, that is after 3 digits it makes groups. So here group 1 and this is group 2. Next step 2. Step 2, what we need to do? We need to consider the group 1 number. So what is group 1 number? We have 167. And in this we need to take the units place. So units place we have is 7 and find its cube. That is 7 cube. 7 cube is nothing but 343. Then takes units place of this number, that is 3. Units place we have 3 here. So 3 stands in 1's place. 3 stands in 1's place of a cube root number. Next, step 3. Step 3, consider group 2 number. Group 2. What we have group 2? Group 2 we have 12, and it lies between the cube number of 8 and it is lesser than 27. So 8 is nothing but 2 cube less than 12, and 12 is less than 3 cube. So among 2 and 3, which is smaller? 2 is smaller than 3. So we need to consider the smaller number. Therefore 2 stands in 10's place. 2 stands in 10's place of a cube root number. Therefore cube root of what number we have? 1, 2, 1, 6, 7 is nothing but 1's and 10's, because we found here only 2 groups. So 1's place what the number stands? The number stands 3. And 10's place the number stands 2. So 23 is the answer, children. That is 23 cube is 1, 2, 1, 6, 7. So here whatever the cube root number are given, cube root numbers, for you it will be perfect cubes only, children. Okay, there are non-perfect cubes also that you will study in the higher classes. And third question, you do it by yourself, children. Okay, and that completes today's class, children. And in the next class, we'll solve HOTS and enrichment questions, children. Thank you. Have a nice day, children. Thank you.